This is 4.3 to 4.4 trig identities and solving trig identities. Trigonomic identities are the relationships between the trigonomic functions sine, cosine, and tangent. There are three fundamental trigonomic identities: reciprocal identities, cosine identities, and Pythagorean identities. Reciprocal identities consist of sine theta equals 1 over cosecant theta, cosine theta equals 1 over secant theta, tan theta equals 1 over cotangent theta, cosecant theta equals 1 over sine theta, secant theta equals 1 over cosine theta, and cotangent theta equals 1 over tangent theta. Cosine identities are tangent theta equals 1 over sine theta over cosine theta, cotangent theta equals cosine theta over sine theta. Pythagorean identities are sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And lastly, 1 plus cotangent squared theta equals cosecant squared theta. You can use trigonometry in real life to analyze all aspects of a geometric figure. The students should have an understanding of the 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. And they should also know special right triangles such as the 45, 45, 90 right triangle and the 30, 60, 90 triangle. He or she should also know how to apply the Pythagorean theorem in right triangles before understanding this concept. Students should also not confuse sine, cosine, and cosecant with secant, as they are very similar but very different in nature. In improving the trigonomic identities, we should only touch one side of the equations, not both. Now, in this problem, we want theta to be an acute angle, so that cosine theta equals 0.3. We want to find the values of sine theta and cotangent theta using the trigonomic identities. So in step 1, we use the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. In step 2, we want to plug in the cosine value, which is 0.3, into the equation. In step 3, we want to move everything to the other side except for sine squared theta to isolate it from in the equation. And also 1 minus 0.3 squared equals 0.91. And in step 4, we square root the sine squared value to make sure that we actually have the sine value, not the sine squared value. So the square root of 0.91 equals 0.953, and this is part A. So sine theta equals 0.953. But in order to find cotangent theta, we need to put, so cotangent theta equals cosine theta over sine theta, and we just plug in the values, which are 0.953 for cosine and 0.3 for sine, which ultimately comes out to 3.177. So in step 1, we want to distribute and multiply everything, so we have one fully formed equation. So we would have secant squared theta minus tangent theta secant theta plus tangent theta secant theta and minus tangent theta squared equals 1. And this is the distributive property. Step 2, we want to cancel out the like terms. So in this equation, we cancel out the middle terms because they are opposites of each other. And this is just canceling. And in step 3, we have the equation secant squared theta minus tangent squared theta equals 1. So this is our equation.